Hello everyone. In today's session, we are going to create entire project by using Raspberry Pi Pico. So this project aims to beginners that how to create a relay card or how to operate a relay by using any microcontroller. So this particular session, we are going to use Raspberry Pi Pico to actuate 3 individual electromechanical relay, which will be the sugar cube relay. After completion of this video, viewer will be able to create a schematic by using KiCAD. They will be able to create a complete PCB and they will be able to generate a Gerber file and how to proceed with the manufacturer. So this session will be very useful and bit lengthy, but it will be very easy to understand. And I have considered a simple schematic for the beginners that they will know how to create a complete PCB. Okay, so first of all, let's begin with by creating a new project. So to create a new project in the KiCAD, first go to the file, click on the new project, and it will open folder. And let's first start to create a new folder. We'll indicate as an relay card. Okay, so we are going to create a relay card by using the Raspberry Pi Pico. Right, it is Raspberry Pi Pico. So after creating a new project and the new folder, these two files will be available here in the KiCAD console. So here we have one schematic file. The extension of that particular schematic file will be .kicad.sch, and for the PCB, KiCAD_PCB. So in this particular file, we will create entire schematic, and in this file we will create entire PCB. Okay, so first of all, let's begin with the schematic. Just double click on it. It will open a blank window, and some tools are available on the right side, on the top side, and on the left side also. So as per our convenience, we will use individual tools and create a complete schematic. So first of all, to understand the Raspberry Pi has total 40 pins, 20 on the left side and 20 on the right side. So according to that, we will use Raspberry Pi Pico pins for the schematic. We can create a simple symbol for the Raspberry Pi, or we can do it simply by taking the pin header. We can create a schematic. So it will be easier to use the pin header to create a Raspberry Pi Pico. Okay, so in this particular case, for this schematic, we will use a header to create a Raspberry Pi Pico module. You will know how we can use and what will be the procedure while creating the PCB. Okay, so first of all, let's open the libraries for the symbol. So by clicking here on the this symbol to add the symbol, or you can press A from your keyboard. It will open the symbol library. So we want to add pin header, so we can write it as a connector and underscore. We are going to use a one column, as we know that here 20 pins. Okay, so the one column with 20 rows. So we will use 1 by 20 pin header. So 1 by 20. You can write simply 01 and search it for the around 20 pins. So this is our pin header. According to our convenience, we can take any one of these. Okay, so for now I am considering this and placing it here. So this is our J1 connector is added for the Raspberry Pi Pico. Okay, now let's first of all let us see the schematic. Okay, and we can directly copy and paste here, Control C and Control V. We can mirror, rotate this footprint as per our convenience. For example, I want to move the particular those pins to the outside, and if I want to move this pin on the right side, then simply I can click on the entire footprint. For example, this is our entire footprint. Right click and go to the transform section and mirror horizontally. So pins will be moved. So let us rename it. For example, this is on the left side. Okay, Pico left underscore, and this pin will be on the Pico right. Okay, so we have created a simple Raspberry Pi Pico symbol. Okay, we can create an individual symbol, but it will be easy here in this case to maintain the pins. And see here we have a pin number from 0 to 20. We can rename it, and as per our convenience, we can make it like 1 to 20, 21 to 40. But in this case, it is okay not to change the pin number because both are different footprints. So we will handle it in the PCB side. Again, I would like to use, for example, this is the Raspberry Pi, right? So by using the pin header, we can mount this Raspberry Pi Pico on these particular headers. And I would like to use another external headers on the left side and on the right side. So If you want to take any input or output from the Pico, so it will be easy for us to change the make any changes in the board, or we can add extra sensors or any other actuators. So let's add one more columns of external headers, and let's mirror it. Okay, so we have one more thing, and let's copy and paste for this side also. Okay, so this is for the Raspberry Pi Pico mounting, and this will be the external peripherals. Inputs or outputs can be collected here. And now let's connect all the pins to its header. Like one will be connected to 1, 2 will be connected to 3 will be connected 3. So it will be very lengthy process. To make it easy, you can use a insert button from your keyboard, so it will be automatically added to the header. So see this, it will be automatically added. Each insert button press, it will add one row, right? And same for this, you can add single one and press insert button from your keyboard, it will add all the rows here. Okay, so now we have added a header for our Picos and header for the external peripherals. Okay, so now first of all, as we know that Raspberry Pi Pico has a multiple pins, and each and every individual pins has its own naming convention, right? So you know that the pin number 3 has a ground, 8 has a ground, 13 has a ground, 18 has a ground, like 23, 28, 33 and 38, right? Okay, so first of all, we will provide a ground tag to all the internal pins. So here there is no need to add a ground because ground is internally connected. Okay, so first of all, let us be renaming all the pins for the grounds, and we will also use the power supply or the VCC pins. So we will rename as per our convenience. And as we are going to make a relay card, so let's first add the relay modules. So currently I am using G5LE relay, which is so G5LE1 will be the sugar cube relay. So I am simply searching it on the symbol library, and you can rotate the symbol as per your convenience by pressing R on your keyboard. Okay, so I am adding a first relay here. I think I would like to make our PCB by using the 3 relays. So I have placed the 3 relays. Now I would like to add 3 screw terminals which has 3 pins. So 1 by 3 will be better. Okay, so this is my screw terminal. First one here, second one is here, and third one is here. And relay should have one diode with in parallel with coil. So I am using US1A diode. So yeah, it is available in our symbol editor. So this is our first one, this is our second one, and this is our third. Okay, and again the relay will be actuated by using a transistor. So let's add one transistor. So currently I am using MMBT 3904 transistor to turn on and off the relay. So this is our Q1 transistor added here for this first relay. This will be for our second relay, and this will be for our third relay. Okay, so this is how we have added our 3 transistors. You can arrange by pressing clicking on the transistor and pressing on your keyboard. So according to your convenience, you can align your transistors. Okay, and now to connect relay coil with our diode, you can just hover the mouse on your pins, and you will see the connection will be shown there. So just click on it, and it will connect with the diode. So connect all the diodes with the relay coils. So now we have connected relay coils to the diode, and now let's add collector of our transistor to the relay coil. Okay, so our 3 number pin transistor will be connected to the relay coil. Okay, and now we are providing a ground to our transistors. So you can find the ground in the power section and simply type GND. So ground will be appear here, and simply connect it. Okay, you can copy this entire section and place here on the entire transistor sections. Okay, now on the base side we are going to add one resistor. So simply type R_small, and I'm using the US standard resistor. So simply place here and provide a connection. You can copy and paste entire section Okay, so here I am using 110 ohm resistor, so I am writing it 110 E, copy, and you can paste on every components. Okay, so now I have placed the resistor on the base side. I would like to add one LED, so whenever this relay will get actuated, so LED will glow. So let's put one LED from the symbol section. So simply type LED. LED will be available here, and rotate it and connect. You can copy the entire section from here and copy and paste. Now I would like to add 3 more connections here. Now our overall relay connection is implemented, and now there's 3 connections remaining, which will be connected to our output terminal block. So if there will be any AC load or high power load, so it will be connected here. So the 3 number will be connected as per my convenience. As per your convenience, you can swap the connection here. Okay, so the 3 goes to 1, 3 goes to 3, and 1 goes to 2. And the same connection will be for the third relay, and this one will be connected to. Okay, you can move this connection and reconnect it. Okay, so this is how our relay segment is connected. Now if you want to understand this section, then you can find that this is the coil, right? And if the transistor gets input from the Raspberry Pi, it will work as a switch. So this connection will be connected to here, so transistor will be on. So it will provide a ground to relay, means we have to add a power source here. We will add power source to the relay for the actuation. Okay, so first of all, let's add power supply to our relay. So whenever this transistor will on, for example, if the relay we are going to use a 5 volt relay, so the 5 volt will be provided here. Okay, so it will pass through the relay and through the ground. So circuit will be closed and relay will be actuated, and this contact will move from pin number 4 to pin number 3, right? So in this case, we know we are going to add V bus as a title for the supply. Okay, so we can use this global label, for example V bus, to our supply, or the another alternative is a netlist. So we can add V bus as a title. So see the difference between the net label and the global tag. Okay, so if we are using a multiple pages of the drawing, then we have to use the V bus tag. It will be global in all the pages. Means, for example, this is our first schematic, and we will add a multiple pages, right, by using those 2 tools. In future videos, we will use those multiple sheets and multiple import section pins. So we will use a global tag at that time, but currently we are only using one sheet, so it will be better to use the net labels. We will add V bus to those wires, individual wires. Okay, so we have add V bus here, but from where this power will come? Okay, so from the Raspberry Pi pin number 1, it will provide power to all the relays, right? So individually we are thinking that only one relay will be actuated, so it is enough for the Raspberry Pi to supply the initial current. Logically, this schematic will need more current on the relay coil side, but for the understanding, it will be easy to actuate a single relay at a time, and we are using a smaller rating relay, so it will be better for us. Okay, so this will be the V bus, and you can see that there is no any physical wire coming from this 1 number pin to this connection. Same for the second relay, same for the third relay, but this tag shows that it is not physically visible that the connection is going from here to here, but electrically is connected from the Raspberry Pi pin number 1 to relay number. So electrically it is connected. So by using the labels, we can make a simple schematic. Okay, so there will be no more connection, but it is indirectly connected by using the net labels. Okay, so this is how we have completed our relay section, but the inputs are still pending. So from which pin out of 40 pins, from which pin it will get input to actuate the relay? So I am adding 3 more net labels For example, I am using Raspberry Pi pin number 22 to actuate a first relay, which is GP22. So let's add net label for the first relay, and for the third relay, I am using the another tag name, pin number 21 and pin number 22 for the third relay. So 21 number for the second relay and 20 number for the third relay. Okay, so where pin number 22, 21 and 20 located, and you can see that the pin number 20, 21 and 22, you can see that the physical pin numbers are different and GPIO pin numbers are different. So 20, 21 and 22 are shown here, but actually the GP 15, 16 and 17 were there, but we are going to use the 20, 21 and 22. Okay, so from the bottom, the first, second, third, fourth, 5, and from the 6, 7 and 9 we are going to use as a GPIO pin. Okay, so according to our requirement we will use our pin number. Okay, so the first, second, third, 4, 5, 6 and 7. I think 14th number pin is used. The first, second, third, 4, 5 and 6. 6 will be the GPIO 20. So 1, 2, 3, 4, 5, 6. Okay, so it will be GPIO 20. Let's verify once again. 1, 2, 3, 4, 5 and 6 pin will be 20. 1, 2, 3, 4, 5, 6 pin will be 20. Okay, so again Control C, Control V for the second pin, and the 7 and 8 will be ground, right? So 1, 2, 3, 4, 5, 6, 7. 8 will be ground and 9 will be GP22. 9 will be GP22. Okay, so 20, 21, 22. 20, 21 and 22 are connected in our schematic. Now let's add all the grounds. The ground pins are on the pin number 3, pin number 8 and pin number 13. Okay, so 3, 8 and 13. Let's add a new tag as an ground tag, G and D, and another pin will be on 8 and another pin on 13. Let's verify on the 13 and another ground is on the pin number 18. Okay, now on the second side, so from the upper side, the third pin, exactly you can see that the horizontal matching on the opposite side also there. Okay, so we have ground added here, so we can add the 3 number ground here. Same on the 8 number, same on the 13 number, and same on the 8 number, right? So the ground tags, net names are added here, the wire tags are added for the ground tag. Okay, now to reset the Raspberry Pi Pico, we have another pin which is a pin number 13 and it is known as a run pin. Okay, so we will add one push button to reset the Raspberry Pi Pico. Okay, so let's add a push button by searching it on the symbol library by simply searching on push button. So it will be very easy. Okay, so SW push. So this is our normally open push button. So whenever we will press this button, it will provide a ground that particular pin. So Raspberry Pi Pico will be resetted. So let's copy the ground from here, copy and paste. Connect this ground and let's add one more net label as an run. Okay, and Control C, Control V, and it will added above the GP22. Okay, so now we have completed entire connection for our Raspberry Pi Pico, and we have provided VBus, we have provided the ground. Okay, we have added a reset pin, we have added a 3 relay which will be activated by the means of a transistor. Okay, so our entire schematic is completed. Now let's check is there any error in our schematic. So there is already internal ERC checker available in the KiCAD. Simply press on run ERC, and now we have one error, okay, which shows that the input pin is not driven by any other input pins. Okay, so see this on all the ground we will find this error. So simply to eliminate this error, we will have to add the power flag to our ground. So KiCAD can know that this is actually power pin, so it should eliminate from the ERC. Okay, so let's search PWR flag. So see this, simply this flag here, put this flag here, and now let's check our ERC again, and it is showing a 0 violation, right? A 0 error, 0 warning, means we are ready to go. Okay, now our schematic is created successfully. Okay, this is a very simple schematic for the beginners, and now this is only a symbol. This not represent physical footprint. So which type of relay, which size of relay, how many pins should physical relay have, what will be the distance between those two pins. So it will be distinguished in our PCB, actual PCB. Okay, so first of all we have to assign a physical footprints to all the individual symbols. We will have to provide a symbol, physical footprint to those connectors, those relays, those diodes. You want to use through hole pins of the transistor or the SMD transistor, which type of resistor you want to use, which type of LED you want to use. So we have to provide individual footprint packages to all the symbols. Okay, so to add the footprints, you have to use this particular tool. It is known as assign footprint tool. Okay, so by default KiCAD will add some of the footprints to its individual components. Okay, but some of the yellow shaded area does not have footprint. Okay, so we have to add manually. To add the footprints, first of all we will select two components on the footprint filter side. Okay, if you want to add a manual process, so you have to add use the library section. But KiCAD will by default, based on the description and based on the pins, it will filter out on the right side. Okay, so for the LED, I would like to use a 1210 package on the SMD side. So it is here 1210. So simply double click on it, select the footprints, device schematic symbols, and select footprint you would like to use. Okay, and if you want to visualize that this footprint is perfect for us or not, so simply right click on any of the footprint and you can see that this is it will show the 2D footprint, or you can see the 3D footprint also. Okay, so you can rotate and see that this particular LED will be suitable for you or not. Okay, now if you want to check any another footprint, then you can simply right click on the device. You can see the footprint. You can measure the distance between the pairs, to the pairs, the width of the pair, height of the pair. Okay, same horizontal length of the component, vertical length of the component. So as per your convenience, you can select the footprint and sort out the footprint. But for me, it will be better to use the 1210 larger size of the LED. Now again, if you want to see that which particular component is that, so you will click here on the assign footprint window. It will automatically change the component location, and it will indicate that this component is this. Okay, so according to your requirement, you can select the footprints. So for those particular 4 headers, right, for those particular 4 headers, the footprints will be same. So first of all, let's create a right click and we will see so which will be better for us. Actually we are mounting vertically, so we are going to use headers. So yeah, this will be best, but the pitch between those two headers should be 2.54, because if you will see the Raspberry Pi physical specification, 2 pins has a distance of 2.54 mm. Okay, so P should be 2.24. See this. So we are going to mount vertical. So this is the horizontal footprint. So it will be not best for us, and this will be the best choice as we are using the TST part. Okay, if we have a SMD module, then we can use this footprint. Okay, but we are going to use the TST, so it will just double click on it. It will assign to our all 4 headers. Now for the terminal blocks, you can see this. We are going to use a 5 mm 3 pin terminal blocks. So again we have multiple options which type of terminal block you would like to use. Okay, so in my case my preference is that there should be a 5 mm pitch. Okay, so see this has a 5 mm pitch and it is a Phonics standard terminal block. So I would like to number 24 for our terminal block footprints. Okay, and now resistor, I would like to use a 0805 package, and for the push button we can see that there are multiple 2 pins devices are available. Actually we need a 4-pin standard push button. So let's simply scroll down and see there's footprint here. So as per our convenience, we will find the push button footprint. Okay, so we need a 4-pin push button, and we will check the dimension, and it should be a TST one. Okay, so see this, these are the SMD one, but actually we need a TST. Okay, so it should be here. So all they are SMD one. Simply scroll down and you will see the 4-pin push button. This is the 12mm. Actually we need nearly 5mm one, 6mm, 4.3mm, and yeah, 5mm. So now we have a 5mm, 6mm by 5mm push button. Simply double click it, okay, and close this window. Now you can see that we have assigned all the footprints to its individual components, and simply press OK. Save this schematic and directly jump on into the PCB section. So again it will open the blank window. You can close this window and directly jump into the PCB layout editor, or you can simply click here and you can go to the PCB layout editor. If you want to go back to the schematic, simply click here, it will go to the schematic editor. Now let's go back to the PCB editor, and you can see that there is no any component that we have added to the schematic. So to import those components into the PCB editor, simply click on update PCB from the schematic. It will open one window, and you simply have to add use this update PCB button, and it will add all the devices, all the components that we have added on the schematic will be visible on the PCB, but it is not arranged properly. So we have to arrange all the devices and the components perfectly as per our convenience. Okay, so now let us first see the 2 pins. Okay, so actually we have added 4 headers here. So first of all we have to distribute those 2. So you can click here, it will show on the PCB editor, right? So we can see that this is the left side. So first of all we will take this header which is on the left side, and now let us take this header which should be on the right side. Okay, same for this, it should be right of right, and this should be left on left, and this should be on the right on right. Okay, and now we have to adjust the distance between the Raspberry Pi Pico header. Those 2 exact left and exact right headers are we can adjust as per our convenience, but this should be as per standard. Okay, because the Raspberry Pi pin header has around distance from the center of 2 pins header on the vertical line. It should be a 17.8 mm nearly. Okay, all the units are in mm. So we should adjust those headers around 7.8 mm pitch. Okay, so we can use a measure tool, and around 17.8 mm. Okay, so this is how we can measure the distance between the 2 vertical pin headers, 17.8. Okay, and now simply move and adjust here. Simply move and adjust here. Now delete this particular measurement. Okay, and again move and adjust here, again move and adjust here. Okay, so first of all we have to arrange exactly on the horizontal distance. We have to match. So first of all, to arrange both on the same alignment, we have to arrange 4 in the same alignment. So simply click on all the headers, or you can do one by one, because now we cannot change the distance or the length or the height or the width of those 2 headers which is dedicatedly used for the Raspberry Pi Pico. Okay, so first of all I will adjust those 2, and I will align this particular connector with this particular header connector. So simply right click on any one of the header and go to the align and distribute, and click on the middle, and same for this, click on the middle. Okay, so now we have adjusted here, but now you can see that if you will use a measure tool, the distance is around 11.8 mm, and from here the distance is around 12.5 mm. So it should be same on the both sides. So let us use a measuring tool, and let us select around 17 mm, 16.5, around 17. Okay, and same, Control C, Control V, and from here we have. Okay, now simply press M and adjust here. Simply press M and adjust here, and again delete the dimension. Okay, so we have adjust a Raspberry Pi and external peripherals header. Okay, now let's check the push button. We will add push button here in the vertical manner, for example. Then we will use the 3 relays. Again, the top one first. So this is our top relay, so it should be here like this. We will arrange as per your convenience. Again, the third one is like this. Okay? So first of all, roughly we will place all the components. Now let's take a first diode, which is here. You can rotate by pressing the R, moving by pressing the M, and same for those diodes. Okay, now let's take the transistors. The first transistor is here. Now let's second transistor is Q2, and the third transistor Q3. Okay, so our transistor is completed. Now the terminal block individual. So let's take, this is the first one, this is the second one, and this is the third one. Okay, so 3 transistors completed, and now let's take first resistor. Now let's take this second resistor, and now let's take this third resistor. And now let's begin with the LED. The second LED, and the third and the last LED. Okay, so now we have roughly adjusted our components, and now let's finalize, give the final location to our all the components, so that we can minimize the PCB size and reduce the cost of the production. Okay, so those are our connectors. It should be aligned with the relay, and same diode. And you can see that this is the extra text. It should be not here. This is just for our reference, so we can remove the front fabrication and bottom fabrication, so it will be great to see all the components. Okay, now first of all, let's arrange the connector titles, J5, J6, and J7. Okay, now let's adjust the relays. First of all the relays should be on the same line, so select all the relays and align to the horizontal center. So all relays are aligned to vertical center. Okay, and now let's arrange relay with respect to the connector. Again with this connector, again with this connector. Okay, I would also like to move this diode with respect to this central pad, but first of all let's arrange vertically, then we will arrange horizontally. Okay, so first of all, select a pad, select a diode, click on the pad, so pad will not move. Okay, and adjust the diode, and same adjust for all another 2 relays. Okay, so this is how we have adjust connector and diode with respect to each other. Okay, one more thing, we can move this diode a little bit here, little bit near to each other. Okay. Again you can see that the alignment is changed. So again let's first change vertically, and then we will distribute horizontally, vertically. Yeah, so the distance between to connect same. Again we will adjust those 3 relays on the vertical side, and then we will arrange all the diodes also on the vertical side, okay, and arrange all three components in the horizontal manner. Vertical center, horizontal center, distribute is the same, arrange. Okay, so this is how our relays are arranged. Now let's add more things. Actually, I have hide those connections, so you may have those connections visible, but you can visible and hide and unhide from here. Okay, so currently I have unhide. Now it is better to use the connection. Now let's adjust the transistors near to the diode. So to adjust the components, simply click on this pad and this pad. First of all, it should have a vertical position for all the components. So let us arrange the vertical position perfectly. Make as near as possible. Now adjust all the diode pairs. Simply, you can do it manually, but this is the best way to align the components. So it will take much time, but for the routing it will be very easy. Okay, now let's adjust this pair and this pair vertically. Again for those two components. And it is arranged vertically. Okay, now let's adjust the LEDs with pairs vertical. Let's move it here and vertical. First of all, let's move to the near and vertical. Okay, so this is how we have adjusted all the components. Let's move it as possible, as near to as possible. Okay, so this is our push button. Now let's create a rough border, and this is a copper layer, you can see here. So machine will not know where to cut. If you can see the 3D model, it will show the error, right? So it should be changed to the edge cuts. Okay, so now the manufacturer will know this is the edge cut layer, and from here we have to provide a cut. Okay, now you will not see any error here. So finally we have aligned all the components for a final routing. Okay, so first of all, let's add some basic tracks as per our requirement. We can reduce this distance if we wanted to reduce, but for this it is okay for us, and we are not going to add change the distance. Okay, so now to add the tracks, you can see the rough connections that KiCAD provide a suggestion. So as per schematic, that particular pairs should be connected to each other. Okay, so to connect the connection, we have to use this route track button. Just click on it and you can simply do the connection. Okay, now you can see that we have successfully connected one number pin with one number pin on the J2 and J3. But if you want to change the width of this connection, you can do by multiple ways. So first way is clicking on the track, use net classes, and go to the edit predefined sizes. So here on the width panel, you can add multiple widths. For example, 1, you can add 2 mm track, you can add 3 mm track, you can add 4 mm track, you can add 5 mm track. Okay, you can add multiple. You can also set up the bias and differential pairs, but for now let's limit it to the width of the track. Press OK. So the table that we have just created, it will be updated here. So for now, let us take a 3 mm track, okay, and go to the route tracks and click 1 to 1. See that the 3 mm tracks are visible. But in our case, we have to use the 1 or 2 mm tracks because the distance is very small between the two pairs. Okay, So the track is 2 mm and it is a bit larger, and for now we will use a 1 mm track for all the individual connections. Okay, so let's connect all the tracks to its individual GPIOs. And we are not going to connect the ground tracks for now. I will let you know in future that why we are not going to connect the ground tracks. Okay, now you can see that we have provided connection on the front copper side. That's why it is on the red color. You can see that this is in the red color. But if you want to route on the bottom side of the copper, then you can select the bottom, click on the route track, and it will be going to connect. Okay, now another way to change the width of the connection, you can simply click here, and now you want to change the width of the track. Simply press Q on your keyboard, and let's take 0.5 mm track. Simply type 0.5 and press enter, so it will change to the 0.5 mm track. Now you can see the difference. Okay, and this track is connected on the bottom side of the PCB. So in this particular section we are going to create a 2-layer PCB. So it is a very tedious process to each and every time click here and here to change the layer. Okay, so now this arrow is visible here on the front copper, so the new track will be in the front layer. Now if you want to change the layer, simply press V on your keyboard. You can see that it will automatically bottom layer is selected. Now you can again toggle the layer by multiple pressing of the V. Okay, so this is the simple way to change the width of the track and change the layer of the track. Now again we want to use the front layer, so press V on your keyboard. It will automatically change the layer, and we have a track. Now you can see that the track width again automatically changed, so we can select the 2 mm track and route here. Okay, as per your convenience you can change the width of the track, but for now let's make it default on the 1 mm side. Let's connect all the tracks with the pairs. Pin number 17 to 17, ground will be skipped for now. 20 to 20. Same for here, the bus will be connected, 2 number will be connected, 4 to 4, 5 to 5, 6 to 6. Same, 7 to 7, 8 is the ground, sorry, and 9 to 9, 10 to 10, 11 to 11, 12 to 12, ground will be skipped, 14 to 14, 15 to 15, 16 to 16, 17 to 17, ground will be skipped, 90 to 90, 20 to 20. Okay, so great. Our basic connection with the GPIOs are done. Now you can see that this button has one connection, so we can connect a button. Click here, and you can adjust the track, and go to 11. Same, ground will be skipped for now. Front will be connected to run. Okay. Now, in this case, for example, LED will be connected to 12. For example, if you want to adjust the track, right, like you want to connect like this, okay, or you can connect like this, okay, and you can see that there are extra bulbs on the track. So to remove the or adjust the track, you can simply click on the any section that you want to edit, and simply press D on your keyboard. You can move the tracks as per your convenience. Okay, so for now let's adjust like this, and for this you can see that now this track is very near to each other. We can adjust, select the track, adjust the track, select the track, adjust the track. Same for this, select the track, adjust the track, and same for this, select the track, adjust the track. Okay, so now this is how we can adjust your track. Select, press D, and same for this. Okay, so now we have connected our LEDs to our GPIO pins. Okay, now you can see the vertical connections with the resistor, and now we have to change the width because it is bit larger. We can make the change and press select the track and press delete on your keyboard. Now if you want to add a 0.5 mm track, so first way you can add a plus, and 0.5. So it will add a 0.5 mm track. Simply select a 0.5 mm track and click here and click, right? Okay, this will connect to the diode. Again, this will connect to the diode. This will connect to the diode. Okay, ground will be skipped for now. Okay, so again, V bus. We want to change the width of the track. You can simply press Q, type 1 mm, and 1 mm track will be selected. Again, press Q, 1 mm, 1 mm track selected. But each and every time you have to change the width of the track. So by default, it will be better to use 1 mm track and select from here. And connect to V bus, connect to wire. Again, the track width is changed. So just deselect this, select 1 mm wire, and it will be always 1 mm wire will be connected from here. Okay, and if you want to adjust the track, you can simply click on the track, press D on your keyboard, adjust the track, click on the track, adjust the track, same, press D, adjust, select, press D, adjust, select, press D, adjust. Okay, so this is how we have connected. Now one more connection which is coming from here to V bus. Okay, so we can do it like this. Now let us practice that how to use wires to connect all the tracks. Okay, so first of all, let's use one track. Press V on your keyboard. It will automatically put one wire. Click here and it will goes to the bottom layer. Okay, now you can adjust, move this track entirely to the last section. Press V on your keyboard. It will again put one wire and it will change layer from bottom to the top side. You can adjust this connection by clicking and pressing D on your keyboard. Again, you can change the wire by pressing the D. So this is how you can adjust the wire. Okay, now we want to, this is on the front layer, this is on the bottom layer, right? So if you want to make a connection, again click on the route track, make one track, and when you will be on a bottom layer track, press V, it will automatically connect it, and click to connect the wire. So this is how we have connected front layer and bottom layer with the V bus connection of the diode. Okay, the same thing we can do here and same thing we can do here. Okay, now as we know that there are many multiple grounds, so it will be better to use the ground plane. Okay, so there will be no need to route all the ground tracks. So simply, if we will add one fill zone here by pressing one rectangle, you can place a fill zone in a multiple ways. So I am using another way to place the fill zone. You can adjust the area. Okay, so this is how we have placed one shape. Simply right click on the shape, create from selection, and create a zone from the selection. Okay, and we would like to add a zone on the front popper, and it should have a ground plane. Okay, and press OK. Now you can see the plane is created. Simply to refresh the plane, press B on your keyboard, so it will refresh the plane, and you can see that all the ground planes, ground zones are created, and there is no need to place individual tracks. Okay, you can simply make some space so that this popper will flow from here to here. Okay, so now this is how we can create the ground plane, and this will be as it is. Now let's connect those connections. This particular relay connections maybe have a higher current, so we will use the higher width of labels on the top side as well as on the bottom side. But for now, let's add on the front side. You can use it on the bottom side also. For example, if you have a provided connection on the top side, now you would like to change those connections to the bottom side, you can simply select all the tracks. Okay, press E on your keyboard, or you can select it and filter out. So if you want to change the entire track to the bottom side, okay, so you can select entire track and go to the bottom. Okay, Again, you want to change the level, you can select entire track, press E on your keyboard, property window will be open, and change it to the bottom layer. And for this section, you can see that if you will click on this track, the entire track will not get selected. So to select entire track, press U on your keyboard, it will select entire track, and now press E on your keyboard and it will open the property window and select it to the bottom. So now let's change all the layers to the bottom. Okay, or you can read out if you want to read out entire thing. Okay, and you want only tracks selected, you can see that the pairs is also gets selected. If you will press delete, it will delete entire connectors. Okay, but if you want to filter out only tracks, so select the section in which you want to select the tracks. So click here. So you want to only select the track, select the area, click anywhere on the area, go to the select and go to the filter selection item and deselect all the item, and you would only like to select the tracks, right? So only select the tracks and click OK. So it will select all the tracks and you can delete all the tracks available on the PCB. Now select the bottom copper and you can read out entirely on the bottom layer. So there is no need to change the individual track level. Okay, so this is how we have completed our PCB, and if you want to see then you can see that this is how our PCB looks like. But to make it more sophisticated and a proper way, so you can adjust the button by adjusting it on the inside. Okay, we can change the border by pressing the D, it will get refreshed. Change the zone, press D, it will be refreshed. And let's add some rounded corners. So take arc, okay, and select a corner, select a radius around 2 mm and create an arc. You can see that this is on the bottom copper. So let's change the layer to the edge cuts by double clicking it and select the edge cut. Okay, to rotate it, R, press R on your keyboard and adjust the track, adjust the corner, and let's copy and paste and put in entire PCB outline. Adjust the track exactly on the middle, Ctrl C, Ctrl V, on the left bottom corner. Again adjust the track, check it twice, okay, perfect. And now on the last left top corner, adjust the corner, perfect. Now delete the existing rectangle and select a line, select the edge cut layer and click here and connect the line of two corners. Okay, connect the line of two corners. You can see the width of the line is currently different. We will change it manually either on the corner or either on the line. Okay, now you can see the double click on the, it has a width of 0.2 mm. So let's make change in the width of 0.2 mm. Copy, paste. Okay, change the bottom line width, change the left line width, and to change the top line width. Okay, so now we have created a rounded corner of our PCB. Now let's go back and see this. This is our relay card is prepared. If you want to add text, so you can simply take a T on your keyboard, place your title, for example relay card, okay, and you can put it here. If you want to change the text size, double click on it and it should be on the front cell screen. Okay, we may get error if it will not follow the criteria of KiCAD. For example, if you want to make a 2, for example if you want to make the thickness of the text, for example 0.7, we may get error. According to default setting, you can add the text. See that the text is added here. But now if you want to add the same text on the bottom side, right? So copy and paste text here, click on the E and select the bottom cell. Now you can see that we have added a text on the bottom side, but it should be proper. You can say that it is on the rear side, but the text is 180 degree shifted. Okay, so to shift the track which is on the bottom, select the text, press E and click here on the mirror button and adjust the text as per your convenience and click on the view. Okay, so on the front side text is proper and on the bottom side text is proper. Okay, so this is how we have added our text. Now for example, as per Raspberry Pi, here for example this is a V bus, right? So we have to add the text here. So simply go to the text editor, type VBus, press OK, and you can put a text here. Okay, for example, if you want to add a ground pin text, you can click here, adjust the text as per your convenience, double click on text and put ground. Okay, if you want to highlight the text, you can use a knockout so that it will highlight the text. You will see the 3D model and you can see this the text is not visible here. Why? Because we have selected a wrong level. Okay, so let's change the level of the text to the silk screen, front silk screen, and same for the front silk screen and same front silk screen. Okay, now let's go back and view 3D viewer and our text is visible. You can copy and paste text wherever you want. For example, if you want to add ground here, same Control V, ground here. So this is how we have created our simple PCB by using the Raspberry Pi Pico with 3 relay. Means we can say that we have created a 3 relay card. Okay, and the power supply to this entire PCB will be provided by using the USB slot available on the Raspberry Pi module. Okay, I wish